Today you can learn about how industrial Wi-Fi data acquisition module and bridge work. I will show you our Wi-Fi modules and their applications and setup. Feel free to enter your question into the chat box anytime. So I will talk about how to convert Ethernet to Wi-Fi using Wi-Fi WF-2572 and what's the feature of the Wi-Fi data acquisition modules using our Wi-Fi series and the tiny Wi-Fi series. I will also talk about how to configure the module and their applications. ICP DAS was established in 1993. The headquarters is located in Hsinchu, Taiwan. ICP DAS USA was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers, and we work closely with them to add new features to our products. We also develop new products and to support our customers. Most of our products are RoHS compliant, which means they are lab free. Before talking about the Wi-Fi module, I want to do a quick poll or survey.
Do you hear him? I don't hear him. Are you talking, Steve? I don't want to vote. I can't vote. Oh, my bad.
Okay. Here's the next one. Okay, thank you everyone. Seems like we have 81% using Wi-Fi as the wireless communication technology. So I will talk about industrial Ethernet to Wi-Fi bridge. So this is our WF-2572. It's just released a few months ago. It is an industrial Ethernet to Wi-Fi bridge. The device only needs to connect the Ethernet cable with the module that can create IEEE 802.11 A, B, G wireless personal network. The interface between Ethernet and Wi-Fi uses transparent transmission so that it can convert Wi-Fi to wire internet without complex settings. The WF-2572 also supports the dual bands, which means 2.5 and 5 gigahertz. The 2.4 gigahertz is more crowded than the 5 gigahertz frequency. So therefore, the device on 2.4 gigahertz suffer higher interference than the one on 5 gigahertz. So this is the configuration screen. It is easy and done by the USB interface. So I can connect the PC to the Wi-Fi module, then open the utility from my computer. So it requires connecting to a computer for configuration through the included USB cable. Customer can set the Wi-Fi infrastructure, limit AP mode, and the IP settings using the utility. The configuration will be downloaded to the bridge by clicking the white settings button. So no driver installation is required. So user can connect the WF-2572 to Ethernet enable device that expand their wireless connectivity. So for example, it can connect to different sensor, monitor, and our Modbus TCP remote I/O module to transfer data to computer, PLC, or PAC controller. So this is our Wi-Fi data acquisition module, the WF-2000 series. It allows analog or digital I/O data to send to master device through Wi-Fi. From the picture, WF-2019 reads thermocouples measurements and send data to PLC on the other hand. In addition, the WF-2019 has WLAN connection complies with the IEEE 802.11b and G standards. It incorporates the wireless connectivity into monitoring and control systems. They also support Modbus TCP and UDP protocols and the network encryption configuration, which makes SCADA system integration and the software make easy and safe access for user from any time and anywhere. So this is the list of our Wi-Fi 2000 module. We have Wi-Fi module that reads RTD data, thermocouples, analog, digital input and output. So this is also our Wi-Fi data acquisition module. It's called the WFM-R14. It is a 14 channels relay output module with metal case, which includes stronger protection. Same as the other Wi-Fi module, it has wireless LAN connection complies with the IEEE standard. It support Modbus TCP and UDP protocol, and is good for integrate with SCADA software. It supports also Form A and Form C relays. The configuration will be the same as the other module as well. With the 14 channels relay output, it can be connected to devices such as alarms, fans, heaters, and other machines. PLC can also connect to the WFM module to turn relays on and off wirelessly. This is our latest tiny Wi-Fi module. It is the tiny version of the WF-2000 series. These 5 of them will be able to read digital input and convert to Wi-Fi. To summarize this webinar, Wi-Fi data acquisition module and bridge can read data from sensor and control output wirelessly. They upgrade Modbus TCP device with wireless communication ability and have easy configuration with USB connection. Okay, we have finished our webinar for today. Please feel free to ask any question you may have. You can follow us on Facebook, Twitter, YouTube, Google+, LinkedIn to get the most updated in industrial automation. If you have other questions, you can also call us or email us. Okay, I see we have two questions right now. So the first question is, how does this unit different from basic wireless router? So I think he's talking about the WF-2572. So this one is basically a Ethernet to Wi-Fi converter, or we call it a bridge. So it doesn't assign any IP address to the module or other devices connected. But the wireless router can assign IP address. So this is not a router. Okay, the next question is, must the sensor be wireless or wired? Okay, let's go to a picture. Okay, here is how you connect the data acquisition module to the sensor. So it has to be wired. So first of all, you have to connect your I/O to the WF module first, and then the module itself will send the data through Wi-Fi to PLC, controller, or a laptop in order to read the data through SCADA system or other software. Is there any other questions? So if you have other questions, you can email us or call us. I can also provide you some information, other information with our Wi-Fi module. Okay, thank you everyone for attending. Have a good day.